Introduction to differentiation done by Gerald, Albert, and Mahi. First of all, let's look at differentiation. Differentiation is mainly used in curves because it gives us the gradient of a curve. Let's say we are trying to find the gradient of a point on a curve. I would place a ruler at a respective point on the curve and draw a tangent line. When I move my ruler relative to a fixed point on my ruler, following the curve of the graph, it can be seen that my ruler changes in gradient every time it is moved. Now, if I were to find the gradient on the curve in a particular point, let's say here, I could argue that the gradient of that point is the gradient of that tangent. Then, that's effectively what we're doing, finding the gradient of the tangent. Now, we know that from the basic mathematics, to find the gradient on the tangent, I would work out the difference in y and divide it by the difference in x. In other words, gradient is y over x. The famous differentiation notation that we learn is dy over dx, which is the Leibniz notation, actually comes from this equation. Dy dx gives you the gradient function, in other words, an equation that gives you any gradient from a point in a curve. But first, we need to learn the process of differentiating. Here is my equation of a curve. We now have to find dy dx. Here is a standard differentiation method to get the derived equation. You pull down the n, multiply it by the constant which is x, and then reduce the power by 1. As an analogy, if we have powers, we will fly to the front, and with powers comes great responsibility, so the power is decreased by 1. Therefore, we can apply it to our equation of the curve. To find the gradient of the curve at that point, we have to differentiate the equation of the curve. So, we apply the same method. Bring down 3 to the front and multiply it by x and reduce its power by 1, giving you 3x squared. Bring down 5 to 2 and multiply them and reduce them to the power by 1, giving you 10x to the power of 4. Thus, the gradient of the tangent is 3x squared plus 10x to the power of 4. Now that we're done with the fundamentals, we can now move on to the rules and principles of derivation. In this video, we will be covering the concepts of product rule, quotient rule, chain rule, and rate of change problems. Product rule. Another method of finding the derivative is by using the product rule. The product rule states that if we have two functions being multiplied, we'll call them fx and gx. It states that the product rule is the derivative of one of them, let's say fx first, and multiply it by gx. After that, add that with the product of fx with the derivative of gx. Let's try do some examples to make some sense out of this. Suppose my function is x squared multiplied with x cubed plus 4. In this case, my fx would be x squared and my gx would be x cubed plus 4. The derivative of fx is 2x and the derivative of gx is 3x squared. Now that we have all the pieces of the puzzle, we can find the derivative by putting them together using the product rule formula. After multiplying, adding, and simplifying, the answer would be 5x to the power of 4 plus 8x. And there we have it, the derivative of our equation. Next up, my friend Albert will be talking about the quotient rule.
We're going to look at the derivative involving the use of the quotient rule. The quotient rule says, if you have a fraction and you want to find its derivative, what we do is take the denominator, multiply it with the derivative of the numerator. Then we subtract away the numerator times the derivative of the denominator. Then we divide with the square of the denominator. For example, we are to find the derivative of x squared plus 3x divided by x plus 4. Using the quotient rule formula, the derivative of f of x is x plus 4 times 2x plus 3 minus x squared plus 3 divided by x plus 4 square. The remaining part is just simplifying, which will give us x squared plus 8x plus 12 divided by x plus 4 square. And finally, x plus 2 times x plus 6 divided by x plus 4 square is our answer. Now we're going to look at the chain rule. Chain rule is the rule for differentiating compositions of functions. For example, find dh dx. Using chain rule, dh dx equals to dh du times du dx. Example 2. Differentiate using chain rule the function 3x minus 5 power 4. Let u equals to 3x minus 5. Using the chain rule formula, equals to 4u cubic times 3, which equals to 12u cubic. Substitute the value of u, and the answer is 12 times 3x minus 5 power 3.
In this section, we're going to talk about rate of change and rate of change problems. So what is rate of change? The rate of change of a quantity refers to how that quantity changes over time. In this section, we're going to talk about rate of change in business and economics. So there are 4 functions pertaining to business. These are demand function, revenue function, cost function, and profit function. Demand function can be expressed by P of X, where X is the number of units of a product or service that can be sold at a particular price P. So let's say you have a function which shows the number of apples being sold, and you have another function which shows the price at which the apple is being sold. Expressing the function of the price in terms of the number of apples being sold will give you the demand function. Revenue function. Revenue function can be expressed by Xp of X, where X is the number of units of a product or service sold at a price per unit of P of X. The derivative of the revenue function will give you the marginal revenue function. Cost function. Cost function is the total cost of producing X units of a product or service. The derivative of cost function will give you the marginal cost function. Profit function is the profit from the sale of X units of a product or service. The profit function is the difference between the revenue function and the cost function. The derivative of the profit function will give you the marginal profit function. Now let's look at a problem. A company sells 2,000 toy cars per month at $5 each. Market research has shown that sales will decrease by 200 toy cars for each $0.5 increase in price. So question A. Determine the price function. To determine the price function, we need 3 variables: n, number of $0.5 increase in price; p, price of one toy car, which is 5 plus 0.5n; and x, number of toy cars sold per month, which is 2000 minus 200n. Next, we need to express p as x, and we can do this by finding out the value of n from x, and then substituting the value into p, which will give us 10 minus 0.025x, which is our demand function. Question B. Determine the marginal revenue when sales are 300 toy cars per month. We can find out the revenue function by multiplying the demand function into x, which will give us 10x minus 0.025x squared. To find out the marginal function, we need to find out the derivative of the revenue function, which is 10 minus 0.05x, and by substituting 300, we will get an answer of 8.5. Question C. The cost of producing X toy cars is C of X. Determine the marginal cost when the production is 300 toy cars per month. To find out the marginal cost, we have to find out the derivative of the cost function, which is 0.016x plus 9.2. And if we substitute a value of 300, we will get a value of 14. Question D. Determine the profit and marginal profit from the monthly sales of 300 toy cars. We can find out the profit function by subtracting the revenue function from the cost function, which is negative 0.0025x squared plus 9.84x plus 9.2. And if we sub a value of 300, we will get $2736.2. To find out the marginal profit, we need to find out the derivative of the profit function, which is 0.005x plus 9.84. And if we substitute a value of 300, we will get a value of $11.34, which is our marginal profit. Thank you for watching this video, and I hope we helped you to understand different differentiation methods and rate of change problems.
Created using Powtoon.